Rebonjour à tous. Je ne vais pas introduire longuement la présentation de Stéphane parce qu'on a présenté Stéphane ce matin de façon détaillée, mais pour mémoire, pour ceux qui nous rejoignent également cet après-midi, Stefan Helmreich est professeur d'anthropologie au Massachusetts Institute of Technology, le MIT, et il a écrit des ouvrages extrêmement stimulants à partir de son étude des communautés scientifiques et de leur activité, dans le plus près, dans le plus concret, dans le plus matériel, sur les mondes océaniques. Donc, on avait dans le diaporama projeté la couverture d'un de ses ouvrages, celui-ci, Alien Oceans, et vous avez aussi Sounding the Limits of Life, qui est également un ouvrage très intéressant, dont évidemment on peut que recommander la lecture. Je vais laisser la parole à Stéphane. Donc Stéphane va présenter en anglais. Si certains d'entre vous ont des problèmes de compréhension, qui n'hésitent pas à se manifester dans le fil de discussion et on essaiera d'éclairer autant qu'on peut leur lanterne. Et puis, quand Stéphane aura fini sa présentation, qui devrait durer 30 à 40 minutes, vous pourrez poser vos questions donc en français, dans le fil ou à l'oral, et on rassemblera nos petites connaissances en anglais pour essayer de trouver les bons mots pour les traduire. Stéphane, you can start your conference.
Well, thank you, Alex, and thank you, everybody, thank you for inviting me. It's good to be here, wherever that is. Yes, my talk is called On the Beach. What happens on the beach? One thing is this: waves arrive, break, and swash. Writers, artists, and many others have worked to capture in words, paint, and music how such wave dynamics unfurl. In her 1999 book on waves, Marie Darrieusse writes, quote, "The wave is by its essence a formal modification of matter, with its creation of froth, vapors, sprays, breaks, and shocks," unquote. A long line of visual artists have sought to render these modifications at sea and on the beach in watercolor, woodblock print, oil, and video. Here is a very small sample of some of those attempts at evocation. And there's no end to the evocation of waves in music. And if anybody is interested, a colleague of mine and I put together a 44-minute sound file accumulating the sounds of waves in music from WC to today. It's available here. Waves, of course, are also scientific objects, and the story that I tell in this talk recounts a history of wave research conducted at the Scripps Institution of Oceanography in La Jolla, California, from the 1940s until today. I'm interested in changing scientific motivations to understand waves on the beach, motivations that have moved from the military, timing amphibious invasions, for example, to the recreational, predicting waveforms and forces for surfing, to the ecological, mapping beach erosion and sea level rise. I've titled this talk On the Beach, in part as a reference to the 1957 book of that name by Neville Shute, an end-of-the-world novel about a group of people in Melbourne, Australia, awaiting a wave of radiation consequent upon a Northern Hemispheric nuclear war. There's also a movie made of this book from 1959. Their circumstance, awaiting the uneven spread of disaster, seemed to me to speak to the moment that so many of us are in right now, and also reminded me that much of today's wave science, in fact, originated in the context of war. At this talk's end, I'll also comment upon what COVID-19 looks like amidst the spray of ocean waves on the beach. American wave science was forged in the crucible of World War II, as researchers at Scripps, in alliance with other US institutions, as well as with particularly British researchers, turned their attention to predicting patterns of waves arriving on shores held by the Axis powers. That work turned waves into strategic, if temperamental, environmental infrastructure for the amphibious landings of Allied troops in North Africa, Europe, and Oceania. The script's wave story is usually told centers on oceanographer Walter Munk, born in Vienna in 1917. Munk finished a bachelor's degree in physics at Caltech in 1939, and he applied for American citizenship that same year after the Nazis annexed Austria. He moved to Scripps to start a PhD under Harald Sverdrup, another expatriate European, who had moved from Norway to become director of Scripps in 1936, after leading Amundsen polar expedition in the 1920s. When Germany invaded Norway, Sverdrup extended his stay in the United States. In the 1940s, early 1940s, at the request of the United States Army Air Corps, Munk and Sverdrup began working to determine whether wave height might be predicted to time Allied amphibious invasions, which you see pictured in the photographs here. Munk and Sverdrup's work became decisive for amphibious landings on the beaches of Normandy in June 6, 1944, also known as D-Day. To generate their approach to wave prediction, Munk and Sverdrup first needed to gather data, spatial data. Well, there would eventually exist dozens of wave stations around the world from which observers would report incoming wave heights and periods. Much proof of concept work was done at Scripps, which hosted a very long pier from which observations could be made. You see the pier here in a 1960s postcard. In one Scripps document called Height of Breakers and Depth at Breaking from March 1944, authors report on a preliminary project in which, quote, 4 or 5 aerial photographs were taken of a single well-defined wave as it advanced from the outer end of the pier to the point of breaking, unquote. Such photos were later synchronized with underwater measurements of pressure, which corresponded to the rise and fall of waves at surface. Munk argued that one could use photographically captured changes in wavelength and speed as waves traveled to shore to infer the changing depth of the water beneath. A once confidential document on the, quote, effective bottom slope on breaker characteristics as observed along the Scripps Institution Pier, unquote, provided an illustration. Wavy lines ranged against a grid backdrop, underscoring waves' amenability to measure. To secure confidence in diagrammatic accounts, such as this, the Scripps oceanographers also recruited lay observers, everyday people, to gather more data. And one trace of such projects in the Scripps archives comes in documents chronicling a Navy study of waves in shallow water. So the Navy Department Bureau of Ships in January of 1944 contracted the Woods Hole Oceanographic Institution in Massachusetts and the University of California also to, quote, make observations of waves and breakers along the Scripps Institution Pier and other piers in Southern California as part of investigations which are carried out for the purpose of preparing an urgently needed manual for use in amphibious operations, unquote. A man named J.C. Hammond was deputized to locate people living near piers to conduct observations. His letters to Sverdrup document Hammond running around the coasts of Southern California, providing people, what we might now call citizen scientists, with stopwatches. And Hammond's confidential report of April 16, 1944, which is pictured here, which is in the archives at Scripps, barely contains his exasperation with organizing people into a project of disciplined scientific observation, into getting them to adopt a proper frame of reference. His amateur sociology of wave observers on the beach offers a glimpse of how people in 1940s California occupied and engaged the shore, though it also provides a kind of X-ray of what Hammond judged, drawing on his attitudes about class and gender, to be proper scientific orientation. So as he put it, quote, The problem consisted of locating observers for 7 piers and maintaining their interests 7 days a week over a period of 6 weeks at a compensation of $3 a day in wartime. While this was accomplished apparently easily, there were a few times when there was threatened breakdown. So here are some of the profiles of people on the beach that he offered. And I've given them kind of titles of what kind of character I think he's trying to profile here. Quote, "The Redondo observer was obtained from one of the little fish markets on the pier. His interest has been keen, and outside of the necessity of absorbing much irrelevant and unimpressive amateur meteorological data in order to maintain his sense of importance, no difficulty has been experienced." There is the lifeguard. "The lifeguard at Huntington Beach was located through the city officials and has done a good job. He has had some experience in studying wave heights for surfboard enthusiasts. He is above average in intelligence." Unquote. The oil man. "At El Segundo, the Standard Oil Pier is under strict military guard." So this is interesting, right? This mixture of like the oil company and also the military. "It was necessary to obtain the pier manager and his assistant, and it was impossible to allow them compensation on account of company rules. The manager is a highly paid man with heavy responsibilities. He found the observations to be an annoyance and desired at times to be relieved, but his cooperation was held by stressing the serious nature of the project and its implications. This pier is believed by the writer to be well co-located and these observers of high caliber." There's also the amusement park worker. "Mr. Weir at Ocean Park was obtained through his employer who owns the amusement pier. This arrangement works well and is to be recommended where the employer is a reasonable person." So you get this sort of portrait of the kinds of people at the beach and then also the attitudes that these scientists have toward them. And finally, the one that kind of was most stunning to me, the bored housewife. "The original observer at Oceanside left after 5 days because of an eye injury, but helped locate a successor. This lady is the wife of a civil engineer and lives next to the pier. She was an ideal choice as she has little at home to engage her, and this work offers something to narrow the gap between her housework and the highly technical work of her husband, a gap keenly felt by the more intelligent housewives in the later years of their marriages." Unquote. There's a lot you can say about gender and science and observation and class. Now, the difficulty for Hammond was getting people to enter the frame of reference, both in terms of disciplining their observations and submitting to what he took to be the reasonable demands of science. So these were not people like the narrator of Italo Calvino's short story, Mr. Palomar at the Beach, which features a protagonist who, seeking a moment of contemplation, decides to, quote, "carry out an inventory of all the wave movements that are repeated with varying frequency within a given time interval," unquote. Now, in spite of Mr. Palomar's attempt to enter a kind of meditative reverie, he's gone to the beach to kind of get his head clear, and in spite of his attempt to enter this meditative state of reverie, Mr. Palomar is actually already a disciplined observer. He's already absorbed the language of science. It's already been kind of vernacularized. For early script scientists, everyday people, like waves, were unruly and required disciplined surveillance. It may be no wonder that the next steps in wave observation were trying to automate wave observation, to standardize or turn off the human element, to make waves objective. Record keeping and standards for understanding waves, what waves were, became essential to wave science. In Proposed Uniform Procedure for Observing Waves and Interpreting Instrument Records from 1944, Walter Munk was already offering a rubric for such features as wave height. He wrote, quote, "The wave height shall be taken as the average of the highest 1/3 of the waves observed during a time interval of at least 10 minutes, unquote, spelling out a measure that he would later call significant wave height. And I think that's an important phrase, significant wave height. It's about significance. It's about meaningfulness to particular people. Such measures came increasingly to be embedded in wave monitoring and recording devices. The unfolding story of wave inscription devices at Scripps can be tracked through a run of papers and diagrams in the archives of the institution. from early examples, such as Cecil Lafond's 1938 wave recorder so you see this fellow, Eugene Lafond, with this giant drum that's recording the ups and downs of waves, to a crumply scroll of wriggly wave height measures on October 3rd, 1966, that I once found rolled up in a cardboard box in the Scripps library, a kind of dry archival trace of a once watery wave. So this was a strange archival find. Just here's a diagram of a wave from October 3rd, 1966. Great. How are waves becoming knowable in the mid-20th century moment? Well, through time and motion studies at piers and beaches, but also through something relatively new to wave science, and that's aerial photography. A representation of the sea flipped from looking across the horizon, the seascape, to looking down on the sea as a map of itself. This permitted a view from above. With sequences of shots lined up to create a stepwise kind of cinema, these views could foretell futures by turning wave time into wave space. Earlier 19th century viewings of waves from above developed in concert with a surveying of ocean space from cliffs, a vantage from which, as feminist theorist Tara Rogers has shown, mostly male scientists often describe the sea as a flux to be brought into calculative order by an objective observer. And I always think of the 1818 painting, Wanderer Above the Sea of Fog, here when I think of this. Hermann von Helmholtz, for example, wrote, quote, "A great multitude of different systems of waves, mutually overtopping and crossing each other, is best seen on the surface of the sea, viewed from a lofty cliff. I must own that whenever I attentively observe the spectacle, it awakens in me a peculiar kind of intellectual pleasure," unquote. Now contrast that with Scripps oceanographer Willard Bascom's different approach. This is a picture of an oceanographer called Willard Bascom with a giant ruler in the water trying to measure waves. Now contrast the earlier Helmholtz's approach with Scripps oceanographer Willard Bascom's kind of outdoorsy manliness, as he sought to measure waves from a point of view in the water. So here fusing a dedication to disinterested accounting with an in the thick of it kind of heroism, one that historian of science Naomi Oreskes has argued crafted mid-century oceanic objectivity as a potent mix of masculine detachment and passion, which also effectively erased the labor of many of those women who were tabulating, circulating, and theorizing ocean data from sea and sky. Nuclear detonations in the Western Pacific saw oceanographers from Scripps participating, again, in 1952, when the United States dropped a hydrogen bomb on Eniwetok Atoll in the Marshall Islands. And now we really are in territory close to Neville Shute's On the Beach book. Wearing only bathing suits, Walter Munk and Willard Bascom were positioned on 3x3 foot rafts floating within sight of the impending explosion. And Munk, quote, "became concerned that the H-bomb would trigger a tsunami with distant outreach. We were concerned that the shock of a magnitude 7 earthquake, the thermonuclear explosion, would trigger an underwater landslide. Such landslides are good generators of tsunamis," unquote. Munk and Bascom scanned readouts of bottom pressure to see if there were any heralds of tsunami activity, which there were not. So if predictions for the beaches of Normandy sought to know a near future wavescape, Cold War Western Pacific events figured nuclear weapon shockwaves as virtual proxies for not yet arrived waves of war, even though the test did produce radioactive fallout, doing fast and slow violence to people and environment, as Japanese oceanographer Yasui Miyake argued in 1954. US-based scientists came to live in what anthropologist Rebecca Bryant might call the uncanny present, acquiring, quote, "a sense that what they would do in the present would be decisive for both the past and the future, giving to the present the status of a threshold," unquote. That turned out to be correct, though not so much for preventing the irradiation of Earth's oceans, but rather, in fact, for enacting it, dosing the ocean and the bones and teeth of all subsequent generations with radioactive isotopes of carbon, cesium, strontium, and plutonium, so that now, at millennium's opening, some geologists point to nuclear tests as key stratigraphic markers of the Anthropocene, or maybe what we could also call the Militariocene. It's not clear how many scientists or naval participants developed cancer from this event. What is certain, however, is that this detonation, with many others, was devastating to Marshall Islanders, who developed cancers and passed on a legacy of birth defects to their descendants. The islands and the waters around, which the United States captured from Japan in 1944, had become available as a kind of laboratory when Micronesia became a US trust territory in 1947. The islands of Bikini and Eniwetok are oceanic territories captured by what Winona LaDuke would call radioactive colonialism. American visions of the South Pacific as a tropical beach paradise of isolated islands populated by racially subordinate natives, coupled with the extension of American hegemony over the Pacific Ocean, rendering the expanse into a theater of war, not at all a Pacific space, are the flip side of a vision of the sea as a site for military wave science. Against persistent stagings of the Pacific Ocean as a frontier or space of optimistic futurity, Marshallese activists, such as the poet Kathy Jetniel Kitchener, have worked to keep visible the Pacific as a space of loss and decolonial struggle. The Runit Dome, pictured here on the right, which contains radioactive debris from the US bombing of the islands from 1946 to 1958, is a strong symbol of this devastation on the beach. Run forward now to the 21st century. Nowadays, wave scientists at Scripps are animated much less by military oceans and more by ecological ones. In anthropological fieldwork that I've conducted among wave scientists there, I heard time and again that their motivation for entering physical oceanography and for doing wave science was a concern with the health of the marine environment. So one young scientist made the connection to me this way, quote, "Well, the whole thing is the atmosphere and the ocean interacting. They exchange masses, gases. They exchange momentum. Wind blows on the water and creates currents and energy. They create swells and mixing. And all those interactions go through what's happening at the surface, and those dynamics are dictated by the waves. And also, when waves break, they create bubbles and spray, and you greatly increase the surface area. So if you want to understand how carbon dioxide is exchanged between the atmosphere and the ocean, you need to understand what the waves are doing," unquote. Many Scripps scientists are thinking now too, again, about waves on the beach. Postdoctoral fellow Nick Pizzo in 2017 published a paper in the Journal of Fluid Mechanics called Surfing Surface Gravity Waves, which got very splashy attention from Scripps, which glossed it for the public as about the physics of surfing. And you can see there are these YouTube videos which sort of play up the surfing idiom. And that's likely no surprise. The institution is in a very different moment than World War II, and much of its audience is interested in oceans as sites of recreation and ecology. There's also the matter of sea level rise, coastal erosion, and surf zone pollution. So Scripps wave scientist Falk Feddersen reports on his work on this issue on the Scripps website. And here he is commenting on an article that he's written called "The Competing Effects of Breaking Waves on Surf Zone Heat Fluxes, Albedo versus Wave Heating." This is research that he conducted off of the Scripps Pier. And he writes, quote, "I study how waves come onto the beach, break and dissipate their energy, as well as how sand moves from the top of the beach all the way out to many hundreds of yards offshore. The processes that I'm studying happen on timescales anywhere from an hour to a couple of months. The timescale for sea level rise is, of course, much longer than this, on the order of decades to a century. With climate change, there's also very likely going to be increased storms and wave activity, which is going to act to reconfigure the beach much more strongly than is happening right now, along with sea level rise, unquote. So Feddersen is interested in how waves generate heat upon breaking, which has implications for planning coastal infrastructures. And with the additional interest in material effluent in waves, like sewage, wave breaking becomes a process to be described not only by physics, but also by chemistry, biology, and ecology. So in other words, in the mid-20th century, the people who were studying waves were physicists. And now it's physicists, biologists, chemists, and ecologists. So waves are not just formal processes, but material ones as well. Scripps scientists now look at waves as avatars of anthropogenic damage. So on my last research visit to Scripps in 2019, I met up with an atmospheric chemist called Kim Prather, founder and director of the National Science Foundation Center for Aerosol Impacts on Chemistry and the Environment at the University of California, San Diego. And she told me that when waves crash, they release telling traces of the bodies of water through which they travel. Sea spray is made largely of particles of sodium chloride, but in areas where we were during the interview right then, the coast of California, where the atmosphere is dosed with nitrogen dioxide from car exhaust, a gas that fused with water vapor becomes nitric acid, sea spray also often turns up heavily laden with sodium nitrate. So you can detect in the spray of the waves the composition of the nearby atmosphere. Off the east coast of the United States and off the coast of China, meanwhile, where there is more coal use, spray interacts with gas phase sulfur compounds like sulfuric acid, leading to a legible presence of sodium sulfate. So the spray from crashing waves offers what Kim Prather calls a chemical signal of anthropogenic climate change, or what she called a human imprint. And so she does this work in wave tanks and Scripps. These are pictures of wave tanks there, in which they try to simulate the composition of the water and the atmosphere just off the coast of California. And there's more than chemistry in the mix too. Wave bubbles, and here's a bioluminescence version of what a wave looks like as it crashes. Wave bubbles contain a range of organic materials, from lipids in small bubbles to heterotrophic bacteria in the larger bubbles. In other words, the water is full of little creatures, right? So that the sea spray has a microbiome, a complement of microbial bodies. Exactly which microbes make their way into the atmosphere to be cycled by humans, animals, and plants, and to be incorporated as seeds for clouds, will be modulated by the transformation of ocean biogeochemistry, including changes due to phytoplankton blooms and pollution runoff from things like agricultural effluent, which leads to algal blooms. So Kim Prather made an analogy. She said to me, quote, "Microbes are in your body, and you are composed of more microbial DNA than human DNA. Part of what they're trying to do is regulate the temperature of your body. In just that way, microbes are also trying to keep the temperature of Earth in a healthy range," unquote, right? So the human body becomes an analogy for the oceanic body. Here, wave knowledge is filtered through a medium that has only lately come into scientific legibility, the microbiome. Breaking waves carry and convey fossil fuel histories and shifting microbial ecologies in their bubbling swirls, and now tell a story of a rapidly warming ocean, with likely cascade effects on marine food chains, coral, and kelp ecologies. Microbes may be understood as embedded sensors that deliver accounts of the state of the sea, accounts of possible oceanic futures. So waves become kind of heralds of the future, right? They're carrying messages from a time to come. Earlier this year, when COVID-19 became a matter of concern in the United States, Scripps scientists were asked by Southern California communities whether the coronavirus might travel in aerosols spooling off of ocean waves, a question that was preoccupying beachgoers, surfers, and civic leaders. And Prather early on took a cautious stance, drawing on her expertise in tracking ocean aerosols and reading them for signs of anthropogenic climate change. So that was reported in a late March issue of the San Diego Union Tribune newspaper. UC San Diego virus expert pleads with surfers to stay out of the ocean to avoid coronavirus. Some Southern Californian surfers got angry, deploying predictably US American of the moment language about liberty and accusing those who would restrict surfing of being communists. Right, so there's another story in San Diego. San Diego surfer protests countywide beach closures with "Commies can't surf" sign. Right, so the kind of politics of the mask and all of that stuff that you're seeing unfolding in the United States so horribly right now, came to the beach. So in the event, Prather then modulated her claim, but the episode did make manifest that waves on the beach continue to be full of human questions. Waves are cultural objects, right? They're not just objects of nature, right? They're kinds of culturally meaningful entities, which is why calling the height significant wave height is meaningful. So what happens on the beach? Waves arrive, break, swash, and they do so in ways that convolve sentiment and symbolism for scientists and others who meet them on the beach. Thank you.
Thanks so much, Stefan. It was very illuminating and fascinating.